Okay, so we continue. We can now look at some of the common sketches under projectile motion. Okay, so let's look at a summary from the previous video. So this is a summary of what we talked about in the previous video, the acceleration in the x, acceleration in the y, and these are the formula that we are going to be applying under projectile motion. So it's a matter of just modifying these with some equations depending on the sketch that you're given. Okay, so we'll get back to these formulas. Now, when you look at the common sketches, there are mainly two types of projectile motion. You can have what is known as your horizontal projectile motion. You also have what is known as your oblique projectile motion. Okay, but either horizontal or oblique, the formulas that we'll be applying are the formulas from the previous video, these ones here. Okay, so we'll start with horizontal projectile motion. So it's a sketch in this form where an object has been projected horizontally from a certain height, then it carries out projectile motion. So this type of a sketch is known as horizontal projectile motion. So one thing that you should understand about horizontal projectile motion is that the angle, this body is going to be projected at 0 degrees. There is no angle that is going to be given under horizontal projectile motion. So if it is projected horizontally, meaning theta is taken to be 0. So remember, for horizontal projectile motion, the theta is taken to be 0. Okay, so that's why when you look at these equations here, we can modify these equations. Since we already know that our theta is 0, we're able to simplify some of these equations. Where there is theta here, we just replace in 0, so that we'll apply the same equations for horizontal projectile motion. So what do we mean? Let's start with the one which is here, the initial velocity in the x and the initial velocity in the y. How can we simplify this? So you say the initial velocity in the x is given by VO cos theta. So you say the initial velocity in the x is going to be given by, this is VO cos, what is theta? 0. So meaning the initial velocity in the x is going to be equals to, what is your cos 0? If you punch your calculator, cos 0 is 1. So meaning the initial velocity in the x is going to be equal to the initial velocity which is given here. Same applies if you modify the y. Since you already know the value of theta, you can say the initial velocity in the y is going to be given by VO sine theta. So therefore the initial velocity in the y is going to be equals to VO sine 0. So meaning the initial velocity in the y is going to be 0. So we're just using the same formulas from the previous videos. It's just that for horizontal the angle is 0, so you can further simplify these formulas since we already know the value of theta. So cos 0 is giving you 1, that's why the initial velocity in the x is equals to the initial velocity of that ball, and the initial velocity in the y is going to be 0. So this is how you handle the initial velocity in the x and the initial velocity in the y for horizontal projectile motion. So for example, if they said it was projected horizontally at 18 meters per second, meaning the initial velocity in the x is going to be 18 and the initial velocity in the y is going to be 0. Where is that coming from? Your theta is 0. So we've simplified the first formula, which is for the velocity. Same applies. You can also simplify the formula for the final velocity. So if you start with this one here, you can say the final velocity in the x is going to be equals to VO cos theta. So meaning the final velocity in the x is also going to be VO, since theta is 0 and cos 0 is 1. So 1 times VO, you still get VO. You can also modify the final velocity in the y. So how can you modify the final velocity in the y? You say the final velocity in the y is given by VO sine theta, and then here we said plus or minus g, so you just choose one. So you look at the motion of the body, it's going downwards. So since it is going downwards, the gravity is going to be positive g, since it is moving towards gravity. So you say VO sine theta plus gt. So meaning the final velocity in the y is going to be equals to, we already know that sine 0 here is going to give you 0. So meaning the final velocity in the y is going to be gt. So we've modified the second one and the third one, and this is what we are getting. VO and the final velocity in the y is giving us gt. Same applies. You can also modify the equations for the distance and the equations for the distance in the x and the y. So if you get this one here, you say the distance in the x is going to be given by VO cos theta multiplied by the time. So mean x is going to be VO cos 0 multiplied by the time. Mean the distance in the x is going to be VOT. Okay? Then if you get the one for the y-axis, this one which is here, so how are you going to modify it since you already know the value of theta? So you say the distance in the y is going to be equals to VO sine theta multiplied by the t. The gravity, we said it's either plus or minus, so you just get 1. And the motion of this body is towards gravity, so it's going to be plus 1 over 2 gt squared. Sine 0 is 0, so mean this part here is going to be 0, meaning the distance in the y for horizontal projectile motion is going to be 1 over 2 gt squared. So this is what you're supposed to understand under horizontal projectile motion. So we've just modified the equation. The initial velocity in the x is equal to the initial velocity of the ball. The initial velocity in the y is going to be 0. The final velocity in the x is still 18, and the final velocity in the y is given by gt. Then the x is the initial velocity times the time of flight, and y is 1 over 2 gt squared. Where is this coming from? This is coming from the equations that we got. The only difference is that for horizontal projectile motion, the theta is 0. Okay, so these are the formulas. So how do you expect equation and horizontal projectile motion? So let's look at equation and apply the same formulas. So we'll get back to these formulas which are here. So let's look at an example of equation. So let's consider question 1, where they are saying a ball is thrown horizontally with a velocity of 30 meters per second from a tower 125 meters high. And they want you to determine the time of flight, they want you to determine the horizontal range, the speed of the ball, and the direction just before it strikes the ground. Okay, so when you're given a question like this, the first step is you need to sketch. Okay, so you need to sketch, you visualize what you've been given. So they are saying this ball is thrown horizontally with a velocity of 30 meters per second from a tower which is 125 meters high. Then they want you to determine the time of flight. So the first step is we are going to sketch. So this ball is thrown horizontally. So the sketch is supposed to look something like this. So horizontally in this form, and then it will strike the ground somewhere here. So it is projected horizontally, and the velocity was 30 meters per second. What else have you been told? From a tower which is 125 meters high. So the height of this tower was 125 meters. So this was the initial velocity, and this was the height of the tower which is 125. So from the sketch here, I'm able to determine to say I'm looking at horizontal projectile motion, and the theta in this case is going to be 0 degrees. So they want you to determine, number 1, the time of flight and the horizontal range. So how are you going to determine the time of flight? You look at the data that has been provided. So what do you have? The data that has been provided is you have the height of the tower, you also have the initial velocity. Okay? So remember this sketch that we had. And these are the formulas that we can apply. Okay, so which formula can we use to determine the time of flight? If you've given the height here, you also have the initial velocity. So the only formula that you can use to determine the time of flight is this one here, because your y is your h. You already know what your gravity is, and we are looking for this t, which is here. Okay, so we are saying for you to determine the time of flight, you'll say your y is going to be equals to 1 over 2 gt squared. Again, it's just a simplification of the equations that we got in the previous video, and we got 1 over 2. So this is only applicable for horizontal projectile motion. Okay, so you'll say where there is y is this one here, 125, is going to be equals to 1 over 2. The gravity is 9.8, and this will be t squared. So here you say over 1, and then you cross multiply. So what are you going to get? So you say this is 9.8 t squared is equals to 125 by 2. You're going to get 250. So you divide 9.8, you also divide 9.8. So therefore your t is going to be equals to a square root of 250. 250 divided by 9.8, then the square root of that, you'll get 5.05 seconds. So that will be your time of flight. So again, for horizontal projectile motion, just know these two simple formulas which are here. For x is this formula here, the y is this one. So from the question, you are given the distance in the y, we also had the initial velocity. So to determine the type of flight, this is a simple formula that you're going to apply, and you get your 2 marks just doing that. And then the other question is they wanted you to determine the horizontal range. So the horizontal range is just simply the distance that has been traveled in the x axis. So how do you determine the horizontal range? So we said range is the distance that has been traveled in the x axis. Again, you just go back to your sketch. How do you find the distance in the x? The formula is here. Okay, so you say, oh, the horizontal range is going to be given by the initial velocity times the time. So meaning the horizontal range is going to be, what was the initial velocity? The initial velocity of this ball was 30 meters per second. So you say this is 30 multiplied by, what is the time of flight? The time of flight is what we determined here to be 5.05. So times 5.05. So meaning the horizontal range in this case is going to be 30 multiplied by 5.05, and you'll get 151.5 meters. So that's how you determine the horizontal range. And then the last question is they want you to determine the speed of the ball and its direction just before it strikes the ground. You want to determine the final speed of this ball. Again, you go back to your sketch. How do you determine the final? From the sketch which is here, we said for you to determine the final, you need the final in the x, also need the final in the y axis. So how are you going to find the final in the x? We say the final in the x for horizontal projectile motion is equal to the initial velocity. So therefore you say the final velocity in the x is going to be equal to the initial velocity, which is 30 meters per second. So the final velocity in the x is going to be 30 meters per second. And how do you find the final velocity in the y? We said when you go back to your sketch which is here, the final velocity in the y is g multiplied by the time of flight. So this will be given by gt. So the final velocity in the y is going to be given by, gravity is 9.8 and the time of flight was 5.05. So the final velocity in the y is going to be 9.8 multiplied by 5.05. We are getting 49.5 meters per second. Okay, so that is the final velocity in the x and the final velocity in the y. So if you remember, we said when you determine the final velocity in the x, also determine the final velocity in the y, you're supposed to have the magnitude and direction. So if we have the final velocity in the x, also have the final velocity in the y, we can determine the magnitude. So you can say the magnitude of the velocity will be given by the square root of the final velocity in the x squared plus the final velocity in the y squared. So the magnitude is going to be equals to the square root of the final velocity in the x is going to be 30. So this will be 30 squared plus 49.5 squared. So meaning the magnitude of the velocity is going to be equals to, so 30 squared plus 49.5 squared, and the square root of that, you're going to get 57.5 meters per second. So when you have the magnitude, the other thing that you need to determine is the direction, where I said the direction will be given by tan inverse the final velocity in the y divided by the final velocity in the x. So meaning the direction is going to be tan inverse, what will be the final velocity in the y? 49.5 divided by 30. So meaning your theta is going to be equals to, you can punch 49.5 divided by 30, then tan inverse, we are getting 58.9 degrees. So meaning this is the magnitude and this is the direction. So for horizontal, one thing that you should know is this. We've simplified all the formulas, so these formulas are only applicable for horizontal projectile motion. The initial velocity in the x is equal to the initial velocity, and the final velocity in the x is also equal to the same initial velocity. The initial velocity in the y is 0, the final velocity in the y is gt, the distance is the initial velocity times time, the distance in the y is 1 over 2 gt squared. And this was a typical example of horizontal projectile motion. Okay, so then in the next part we're going to look at another sketch.